We welcome you back to today's ASHRAE Webcast, Making Energy Efficiency a Reality. Once again, our panelists are Chris Mathis, president of MC² Mathis Consulting Company in Asheville, North Carolina; Tom Durkin, senior partner at Sims Durkin Associates in Indianapolis, Indiana; and Mark Frankel, technical director for the New Buildings Institute in Portland, Oregon. In part 2 of today's webcast, we'll hear a presentation case study and roundtable discussion on multifamily and existing buildings, have a presentation and roundtable on policy and energy efficiency, and field questions from you, our viewing audience. So just how do we recognize the significant opportunities for energy efficiency multifamily buildings globally? Chris is here to explain in this presentation existing buildings and residential buildings, taking our solutions where they're needed most. Chris?
If surveys are to be believed, every day ASHRAE members around the world go to work and focus on commercial building performance. Then, at the end of the day, around the world, they go home to single-family homes, to townhomes and condos, to low, mid, and high-rise residential structures. Is the building science of residential buildings so different than what we typically do at work every day? Are people's homes less needful of energy efficiency, durability, quality indoor environments, fresh air, safety, comfort, and the many other valuable solutions we deliver every day than the commercial buildings we serve? How often do we bring our vast understanding of the importance of buildings, the physics and dynamics of their performance needs, and our readily available building science solutions to people's homes? We've already seen that the energy use in residential structures often exceeds that of commercial buildings, and we know where it goes. We've also seen the ratio of new construction to existing buildings. Current projections of planned or needed residential buildings worldwide shows an ever-increasing demand. Another related trend shows mixed-use buildings growing in popularity, providing housing and workspaces, shopping and schools, family and medical services, and an array of other amenities. These mixed-use buildings are evolving into mini cities with even more complex building performance needs and dynamics. Sometimes these renovated buildings have end uses never originally intended. No longer just 8 to 5 operations, many of these multi-purpose, multi-use buildings operate 24/7, 365. And when existing buildings are remodeled and repurposed, they often have very different loads and occupancies, requiring dramatically different systems and solutions than in their previous life. So what do these different operating schedules mean for the energy, power, water, and other demands and services we need to provide? Does the expected growth in residential buildings impact policy decisions regarding energy and power availability? Again, Tom's recommendation about wider peripheral vision is good advice. When we look at the interconnectedness of all these different needs and requirements, we often find ourselves considering things outside of our normal patterns. What about water supply, waste management, opportunities for heat recovery, combined heat and power, safety, resilience, from childcare to healthcare? We must acknowledge that existing buildings pose unique challenges. No two projects require the same solutions. Repurposing existing buildings requires the best of our analytical skills combined with the broadest portfolio of potential solutions. Each project is a one-off, custom. Some will require addressing specific envelope deficiencies, air leakage, under or uninsulated opaque elements, deficient glazing, and fenestration systems. Fortunately, we have a variety of tools we can employ today to help in assessing those seemingly impossible or unseen performance challenges. From IR cameras to blower doors, we now have an array of tools to help us find, assess, and fix previously unseen envelope deficiencies. Often, there are envelope elements that will pose unintended challenges, like design decisions that forget to address known thermal bridges. After we have assessed and addressed these envelope deficiencies, then we're presented with the challenge of updated loads analyses. The size and types of systems used in the building's previous life may have nothing in common with its repurposed intentions. Fortunately, the analytical tools we have today deliver much greater detail and accuracy than when the building was originally constructed and equipped. Such as one of Tom's successful projects, the Lebanon High School. From previous heat-only, unconditioned gymnasia, humidity and energy bill complaints, to a bigger building, air-conditioned, lower EUI, and lower energy costs per student. The renovation or repurposing of an existing building demands the best of everybody on the project. The engineers, the analysts, the architects, everybody. We may go into a project planning to provide our best new HVAC technology and come to find out that the first thing we need to do is plug the holes, manage the water penetration, or insulate the roofs. Depending on the building and its vintage, we may find ourselves facing asbestos or lead-based paints, requiring safety remediation before it can be effectively repurposed. Fortunately, we have an array of tools at ASHRAE that can help with all these building types we've discussed. Our flagship standard, 90.1, provides performance guidance for new and existing high-rise residential and commercial buildings. Remember, over 85% of the buildings we build in the United States are less than 25,000 square feet, so most of them are small. That means that the air leakage of most of them can be tested easily with a few coupled blower doors. Remember, 90.1 delivers the minimum energy performance requirements. Not green, not exemplary, not best practices, minimum. Fortunately, we also have standards that go beyond the minimum, 189.1, 90.2, and others. And ASHRAE has renewed its efforts to address residential building performance worldwide. We have a multifamily design guide already in the works. There's also a new leadership standard for low-rise residential buildings, ASHRAE 90.2, just around the corner. ASHRAE is focusing on all buildings and their energy appetites. And we need to use these new initiatives and multiple standards and the lessons embodied therein to fulfill the goals defined in our shared mission to serve humanity and promote a sustainable world. Thank you.
Thank you, Chris. Now let's go to Tom, who has a related case study from Indiana on energy-efficient multifamily and existing buildings. Tom?
Thank you. Energy efficiency in most multifamily projects will be driven by component efficiency, especially if all the units are to be metered separately. The tables in Standard 90.1 should be the minimum efficiencies that are used, and there may be opportunities for combining technologies, such as heat pump water heaters, to be cost-effective and energy efficient. But if there are shared or central utilities, there will probably be energy efficiency opportunities. Here's a case study of a high-rise multifamily building in downtown Indianapolis. Lockerbie Terrace is a 6-story former office building that was converted to residences in 2002. All 42 units and the common areas are conditioned by water source heat pumps. A rooftop mechanical room has circulation pumps, a cooling tower for heat rejection, and a steam-to-water heat exchanger for winter. The steam came from a downtown Indianapolis district energy steam loop. In 2015, the steam utility determined that they were not generating enough revenue selling steam to Lockerbie Terrace and offered to fund a boiler installation. This is what the 2002 renovation specified for the mechanical room. The pumps were constant speed, and all of the heat pumps had constant flow. Very basic, and it had worked for 13 years. The parameters for running the steam heat exchanger in the cooling tower were not known, other than draining the tower in winter and filling it back up in summer. The system did have a very basic controller on it, but without any remote monitoring or alarms. Now, as an engineer and an energy advocate, I have to confess that there were several things I saw there that bugged me. The loop pumps were oversized and the discharge valves were half closed. Loop water was going through the steam heat exchanger 12 months of the year. Loop water was going through the tower heat exchanger 12 months of the year. Using a 3-way valve on the tower side to modulate loop temperature rather than cycling the tower fans. One other thing I have to point out goes back to the 70s and Mel Wink, one of my early and most influential mentors. Mel was a maintenance supervisor and I was his engineer. One of the many things that Mel taught me was that guys like you, meaning me, never give guys like me, meaning him, enough valves. And I can't help but check stuff like that 40 plus years later every time I go into a mechanical room. At Lockerbie, there were no isolation or bypass valves at either heat exchanger, and there were no isolation valves where the loop piping left the mechanical room. Any issue would require the entire system to be shut down and partially drained summer or winter. Installing the boiler was one portion of the fix. That was swapping steam BTUs for gas BTUs to save money. Now, we did not have access to the steam utilities data, but if our experience at Manchester holds true, where the steam line losses were equal to the steam used at one of the buildings, then there was significant energy savings by the boiler installation. Installing speed drives on the loop pump and the tower fan and eliminating the unnecessary head on the loop pumps were the energy-saving portions. By calculation, the brake horsepower of the loop pump was reduced from 26.5 to 12 for pumps that run 24/7, 365. That was a calculated 1.2-year payback. Now, we widened the temperature range on the loop to minimize both boiler and tower operation. We did not change any of the residence units, and they are all still full flow all the time. We did specify that replacement heat pumps must have the automatic shutoff valves as required by standard 90.1, and we did install a differential pressure transmitter on the loop such that as the residence units need to be replaced, the loop pumps will see the closed valves, automatically compensate, and increase the energy savings. And I put in enough valves to satisfy Mel Wink. Now, this is a graphic representation of the energy bills, which show that the actual savings exceeded the calculated. The installation was done in mid-2016, with 2017 as the first full year operating the new system. Thank you.
And thank you, Tom. And we'll give you a second to get back to our panel because it is time for our second roundtable. We're going to go to our panel to discuss opportunities for energy efficiency in multifamily and existing buildings. All right, gentlemen, it is time to do roundtable number 3. Our first question: what are the special challenges and opportunities for energy efficiency in multifamily buildings? Right off the bat there. Mark, you want to start us there?
One of the biggest problems in tenanted buildings is what we call the split incentive. If the owner is thinking about energy efficiency upgrades, but the tenant is the one who's going to have lower utility bills, there's not much motivation for them to invest in the building. Likewise, if tenants are only paying the bill for their unit, they're not very interested in paying for upgrades to the central area of the building. So that's a classic problem. It's true in rented offices and all kinds of other building types as well.
Multifamily buildings are the largest construction segment worldwide. And a lot of those buildings are mixed use. They've got commercial portions and they've got residential portions. They've got restaurants and laundries. They've got supermarkets and barbershops. Some of those occupancies are 8 to 5. Others are 24/7, the residential portion up top. So they may have really different operating schedules. So it requires a degree of sophistication in building controls and often segregated building controls for those commercial and residential occupancies.
I'd like to ask Mark and Chris about how that question impacts public housing.
Well, Tom hit on something that's really near and dear to my heart. The housing that we build and own with our tax dollars that we provide to our nation's poor, we could probably make a pretty powerful economic argument that it should be the most durable, most safe, most energy efficient because we build it and it's going to be around for a long time. So we should go the extra mile. Now, these folk that we're building this for, they're not deciding on whether to pay their energy bills or go to the movies. They're deciding whether to pay their energy bills or feed their kids. These people are the least able to be wasteful. So we're making an investment and we're building these buildings. They should be among the best buildings that we build.
In this country, in the U.S., we spend something like $8 billion a year subsidizing utility bills for low-income tenants. Instead of subsidizing the utilities to provide the energy services, we should be making better buildings so the utility bills are lower in the first place.
Amen.
All right, very interesting. Thank you, gentlemen. So what events in a building's life cycle can be considered triggers for energy efficiency upgrades? Chris, you want to start this?
A roof leak.
Okay.
How many times do we get to insulate a roof? Well, when the building is first built, and then, we might, patch a roof here and there, but eventually we're going to have to put another roof on that building. So we rip the old roof off. Do we ever have a better opportunity than right then to add roof insulation to a building that obviously isn't meeting current code and maybe didn't have any insulation at all before? So certain maintenance and repair events like a roof leak serve as a really good trigger to create an opportunity that we, in the case of a roof, we might not have that opportunity again for 20, 30, 40 years.
Right, right.
We might look at other events in the building life cycle, new tenants moving in, a building renovation, maintenance cycles. A sale of the building could trigger things. A lot of jurisdictions are thinking about new ways to engage with buildings and trying to encourage upgrades at all those points in building life.
When we repurpose a building, sometimes we're going from maybe one building classification or occupancy to another. Mm-hmm. And so this new, in my hometown, we have a lot of old warehouse buildings that are now being converted into an arts district or condos mm-hmm. or apartments where the building has a daily use pattern that's completely different than it was originally envisioned. So things like that, you can engage lenders and the insurance companies and others because we're suddenly operating that building very differently.
I think that one of the factors that could impact some of these is an election. Changes in energy policy at local or national level, I think, can have significant impact on that.
Very true. All right.
And if I could, I'd like to go back to the previous question. Mm-hmm. We were talking about opportunities in multifamily housing. Right. Chris, yesterday when we were talking about this, you had some very important, stunning statistics about some of the impact on the weatherization program.
Yeah, Tom, thanks for remembering that. One of the things that we found in the low-income weatherization program that we do every year is that when we improve the homes of those who are least able to be wasteful, mm-hmm. one of the side effects is that in-home nutrition goes up. They buy food for their kids. We don't often think about improving a building in the context of in-home nutrition. But that's one of those examples of it's not just about first cost. The economic benefit is sometimes decades long. When in-home nutrition goes up, kids miss fewer days of school, do better on tests. You can see how this would have derivative benefits lifelong.
It's all connected. All right, let's see if we can get one more question in here. How important is the building envelope in EE, and how do we address that?
Well, for me, the envelope is the starting point. It's the starting point for every downstream decision, every derivative decision that we might make on, even something as simple as the siding of a building and the orientation of a building. And then, we have there was an old ad back in the 70s that said, you never get a second chance to make a first impression. Mm-hmm. The building envelope is the first impression that is often going to be with that building for its life. In our country, it's 100 years or more. So that's one that we've really got to get right.
I would say that some of the best, most high-performing buildings being delivered today focus extensively on the high-performance building envelope to reduce all the associated HVAC loads, et cetera. Passive house system is very focused on reducing envelope loads. It's really a pathway to deep efficiency.
All right, gentlemen, thank you so much.